All right, let's dive right in. Artificial intelligence. We're all using it, we're all seeing the headlines, and we all know it is literally reshaping the global economy as we speak. But there's a massive disconnect happening right now. Because most people, even those of us interacting with large language models every single day, don't actually understand what's happening under the hood. And look, if we just treat AI like this mysterious, unknowable black box, we can't accurately gauge its true capabilities, or more importantly, its real-world limitations. So in this explainer, we are going to peel back those intimidating layers and break down the exact mechanics of artificial intelligence together. Here is our roadmap for today. We'll start with the magic versus the reality, then how AI actually learns, followed by narrow versus general AI. After that, we'll look at predicting probabilities, not truth, and wrap up with the real-world impact and risks. Okay, Section 1. The magic versus the reality. So what actually is AI? To answer that, we really need to clear our first major hurdle, completely discarding this modern illusion of sentience. Because tools like ChatGPT communicate with us using perfectly structured conversational human language, our brains are kind of automatically tricked into believing there's a cognitive reasoning process happening behind the screen. It feels like the machine is thinking about our questions, right? Well, it isn't. There is no logical deduction, no emotional understanding, and absolutely no conscious spark in there. It is pure computation, just wrapped up in a highly convincing conversational interface. The reality really just boils down to three words: patterns, prediction, data. At its absolute core, AI is just a vast, sophisticated mathematical system. It ingests an absolute ocean of information, maps out the intricate relationships within that information, and then makes calculated predictions. Think about the predictive text on your smartphone. You know how it guesses the next word you want to type? Modern AI is essentially a vastly scaled up, incredibly complex version of that exact same process. It's just data, patterns, and mathematical prediction. Moving right along to Section 2. How AI actually learns. Let's contrast how humans learn with how machines learn, because it's fascinating. A human toddler can look at a cat, pet it exactly once, and permanently conceptualize what a cat is. We learn conceptually and efficiently. In AI, it needs tens of thousands of images to do the same thing. And it doesn't see fur or whiskers. It sees a mathematical array of pixel values and gradients. It maps the statistical relationships between those pixels until it can reliably predict that a specific cluster of numbers represents a cat. It's brute force statistical mapping, and it requires a massive amount of computational power. And this brings us to machine learning. Back in the early days of software, programmers had to manually write explicit rules for every single possible scenario. But with machine learning, developers feed systems enormous data sets and just let the software map the patterns itself. Take email spam filters, for example. A modern filter can identify a brand new, never-before-seen phishing tactic simply because it recognizes subtle mathematical clusters of suspicious word choices and routing data. So the more high-quality data it processes, the sharper its autonomous predictions become. Now, deep learning takes this a step further by using neural networks. This architecture is loosely inspired by the human brain, utilizing multiple layers of interconnected nodes to process information. Data passes through these layers, with each node applying mathematical weights and biases to filter the inputs. When you see an AI instantly generate a photorealistic image from a text prompt, or clone a human voice perfectly from a 3-second audio clip, you are witnessing deep learning. It absolutely excels at parsing incredibly dense, unstructured data. Section 3. Narrow versus general AI. It is absolutely vital to categorize where this technology actually stands today to kind of calm some of the hype. Narrow AI, which is also known as weak AI, is specialized for specific, bounded tasks. Whether it's a facial recognition system at the airport, a medical imaging scanner, or even the most advanced large language models out there, these are all narrow AI. They are exceptional at their specific programming, but they lack true cognitive flexibility. General AI, on the other hand, implies a system with broad, human-level reasoning across multiple, unrelated domains. That remains entirely theoretical. As highlighted directly in our source material, we are simply not there yet. In fact, computer scientists and researchers actively debate whether true general AI is even theoretically possible using our current technological frameworks. The barrier between advanced statistical guessing and actual causal reasoning is immense. So while the tools we use today are incredibly powerful, they are fundamentally limited by their training data. They cannot dynamically reason their way out of a novel situation that they haven't been mathematically prepared for. All right, Section 4. Predicting probabilities, not truth. Let's walk through the exact step-by-step reality of how generation works, because this is probably the most crucial misunderstanding out there. First, the system processes massive amounts of training data. Second, it identifies the statistical patterns within that data. And third, it predicts the most mathematically likely next outcome. Notice anything missing there? Yeah, fact-checking is entirely absent from the sequence. When you ask an AI a question, it doesn't search a database of truths. It generates a response token by token. If it writes the phrase, "the sky is," it doesn't logically know the sky is blue. It just knows the word blue has the highest statistical probability of following those previous words. Because AI systems do not automatically understand truth, they operate completely untethered from reality. This is the mechanical reason behind AI hallucinations. If the most statistically probable sequence of words happens to be a completely fabricated historical event or a non-existent legal precedent, the system is going to output it anyway. It will present a total falsehood with absolute, unwavering confidence because it literally lacks the capacity to understand the concept of a lie. It's just completing a mathematical equation. Finally, Section 5, Real-World Impact and Risks. Zooming out for a second, understanding these mechanics is so crucial right now because of the massive scale at which this technology is being deployed. AI has moved far beyond tech laboratories. It is actively running in healthcare, finance, military systems, and transportation. It's quietly operating behind the scenes in recruitment software, automatically sorting and filtering resumes by mathematically mapping candidate data against successful profiles. It's often making definitive decisions about human careers before a human manager ever sees a single application. Society is caught in a massive technological tug-of-war. On one hand, we are unlocking incredible benefits, like rapid medical innovation, advanced scientific research, and huge leaps in digital accessibility. But parallel to that, we are facing serious functional risks. Deepfakes are destabilizing digital trust. Algorithmic bias is inadvertently carrying historical data prejudices into automated loan approvals and judicial recommendations. We are attempting to harness an incredibly disruptive force while simultaneously scrambling to build the necessary infrastructure to manage its unintended consequences. So, the future trajectory of AI is not just a coding problem. Because it interfaces so closely with human society, managing it is going to require deep expertise from entirely different fields. As Maya from Privacy Club points out in our source material, the essential frameworks are going to be built around law, ethics, cybersecurity, and governance. Honestly, the most important AI roles in the next decade might not belong to the software engineers building the models, but to the legal scholars and system architects designing the guardrails for how we actually interact with them. So, as AI profoundly changes how we create, search, and consume information itself, here's the big question. Are you ready to navigate a reality driven by predicted probabilities rather than absolute truth? We are still at the very beginning of this paradigm shift. And understanding the pure computation happening beneath that friendly conversational interface, that is your strongest asset moving forward. Thank you for joining me for this explainer. Keep learning, stay curious, and I'll catch you next time.